Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us solve question number 36 of NEET physics paper 2014. Hello students, let us solve the next question number 36. In a Young's double slit experiment, the intensity of light at a point on the screen, intensity of a light at a point on the screen where the path difference is lambda is k. So where the path difference is lambda, the intensity is k. Lambda being the wavelength of light used. The intensity at a point where the path difference is lambda by 4 will be. The situation is very simple. It says that in a double slit experiment, YDSE experiment, this is the center and this is a line over here, this is screen. These are the two sources, S1 and S2 are the two sources. This is center of the screen, this is central bright fringe. Now we are using a light of wavelength. The light that is used is lambda. It falls on the slits and at a point where the path difference is lambda. We know that the path difference is lambda or 2 lambda or 0. Here the path difference is 0 because it travels equal distance. So therefore it is central bright fringe. When the path difference is lambda, again it is central bright fringe. Bright fringe. First bright fringe. So it is also having the same intensity as here. If I am using, suppose that to point, I want to then explain it more better way. This is the point and this is another point. Suppose I call this point P and this point Q. When light reaches to this point, traveling this distance, the path difference is lambda. This is the path difference. And corresponding to this path difference, we are getting maxima, that we know. When here the path difference is lambda, but here the path difference is lambda by 4. Obviously this point will be below this, but for the sake of understanding, I am just drawing above it. Here the path difference, actually as you move up, the path difference will go on increasing, but this is not, diagram is not up to the mark, only to understand this concept. Because here the path difference is lambda, so lambda by 4 will be somewhere here, but that is more complicated to see. So this point Q here, where the path difference is lambda by 4, this is the path difference. This is delta x. And what about the intensity at that point corresponding to point Q? The point P is here. The intensity corresponding to this point P is, obviously we know that 4 times the individual intensity, that is, if the I naught is flowing out from here, I naught is flowing out from here, then this is 4 times the individual intensity. He says that the intensity of at the point where the path difference is lambda is k, that means IP 4 I naught equals to k. So 4 I naught is basically k. Now we have to find what is the intensity over here. So we have to use the formula for intensity of light. You can also see how it becomes 4 I naught, though every student know this, but still I'll just explain you how this is 4 I naught, and then also find the intensity at a point Q where the path difference is lambda by 4, and we will then see how they are related. We know that the formula for intensity at any point, any arbitrary point, any generic point is given by I1 plus I2 plus 2 under root of I1 I2 cos of phi. Now here the two sources S1 and S2 are having same intensity because it is a YDSE experiment. Individual intensity of the sources, so I'll put I1 equals to I naught, I2 equals to I naught, so it is I naught plus 2 of I naught is I naught cos of phi. This is 2I naught plus 2I naught cos of phi. If I solve this 2I naught common, 1 plus cos of phi. Here 2I naught, 1 plus cos theta is 2 cos square theta by 2, so it is 2 cos square phi by 2. It is 4I naught cos square phi by 2. Phi by 2 is the angle. So the intensity at any point is given by this. Now I'll use that equation, intensity at any point equals to 4I naught cos square phi by 2. Part difference of lambda, first point, that is P. I am talking about the point P. The part difference is lambda. Part difference is lambda. So phase difference will be 2 pi, because part difference of lambda corresponds to phase difference of 2 pi. So therefore, I will write that this implies that the intensity at any point P, that this point P, particular point P, where the part difference lambda is given by 4I naught. This formula I'll use, and phi I'll put, this phi is 2 pi I'll put. So it is cos square 2 pi by 2. So this cos pi, and the cos pi value is this is the, and the cos pi is minus 1. You can see here plus 1 minus 1, the cos pi is minus 1 here, minus 1 square is 1, so it is 4I naught. So intensity is 4I naught. That is why I was telling you that intensity at the corresponding to point lambda is 4I naught, which is given as K, so this is your K. So I naught equals to, you can write K by 4. I naught equals to K by 4. Now main question to this question is that at point Q, where the part difference is lambda by 4, there we want to find the value of intensity. If part difference is lambda by 4, then the corresponding phase difference here, because here this is the phase difference that you have to substitute, otherwise you cannot use this formula. Corresponding to the point where the two rays will meet, we will have to determine the part difference, and the part difference has to be converted into phase difference, and that has to be put in this equation to get the intensity of light. So phase difference equals to the, in place of lambda you put 2 pi by 4, that is the phase difference, which is pi by 2. So phase difference is pi by 2. So for point Q, on the diagram as is shown that phase difference is pi by 2. So I want to find the intensity at that point, so I'll use this above formula, 4I naught cos square phi by 2, that means pi by 2 divided by 2, so it becomes pi by 4. 4I naught cos pi by 4 is cos 45 degree, which is 1 over root 2, and if you square it, this is 1 by 2, so into 1 by 2, so this is 2I naught. So intensity at the point IQ, that is at the point Q, the intensity is given by 2I naught. And I naught already we have calculated K by 4, so I substitute that, 2 into K divided by 4, so it becomes K by 2. So intensity at the point Q, where the path difference is lambda by 4, is K by 2, and that should be the answer to this question. If I see the options, then the intensity at the point where the part difference lambda by 4 will be, and the answer is K by 2. That just we got. So this is the answer to this question. Okay, this is k by 2 here, this is k by 2 here, so that is the answer to the question. Okay, thank you.